Hello students, after discussing the historical attempts of periodic classification, we are supposed to discuss the modern classification, because modern classification is what? It is the basis of it. Nowadays, whatever elements we studied them on the basis of the modern classification. Are you aware of the basis of the present classification?
Yes, sir. It is atomic number.
Absolutely correct. Very good. Atomic number is one thing which is being predicted and concluded as the fundamental property of an element. The fundamental property of an element is atomic number rather than atomic mass. Atomic number is being predicted as the fundamental property of elements on the basis of Moseley's experiment. Moseley plotted curve between frequency of X-rays, the root of the frequency, let's say nu, and atomic mass, and he also plotted curve between root of X-ray frequency and atomic number. What was his observation? His observation is that when he plotted curve between root of X-ray frequency and atomic number, the graphs are a straight line. Since the graphs are a straight line, it shows that atomic number is the fundamental property, whereas the graphs are having certain ups and downs in case of atomic mass. So atomic mass is not the fundamental property, atomic number is the fundamental property. That is what is being predicted and concluded out of Moseley's experiment. So it was very much important to us, and it's a milestone for the modern classification. And now we are in a position to discuss the modern periodic law. The modern periodic law. What is the modern periodic law? The physical and chemical properties of elements are the periodic function of their atomic number. That means if elements are arranged in the increasing order of their atomic numbers, repetition in the properties is being observed. That is, you can say, that is, when elements are arranged in the increasing order of their atomic number, repetition in the properties, or we can say periodicity in the properties, is observed. On the basis of Moseley work, modern periodic law is being proposed, and on the basis of modern periodic law, modern periodic classification is there. Now we are able to conclude the modern periodic table, modern periodic law, and we can draw it very well. You can look at the screen. In the modern periodic table, elements are being classified as S block. In the beginning, they are the first two groups that are S block, 1, group 2, there are 10 groups in the D block and 6 groups in the P block. So overall we have 18 vertical columns, they are called groups. So overall in the modern periodic table there are 18 groups. If we classify according to the period, then we have, in the modern periodic table, we have 7 periods, 7 horizontal columns, that is called 7 period. If we start from, in the first case, hydrogen, lithium, sodium, potassium, rubidium, cesium and francium. So in this way we have 7 horizontal rows, they are the periods, and 18 vertical columns, they are the groups in the modern periodic table. In the modern periodic table, elements are being classified. Besides, basis of the classification is the electronic configuration. Besides that, they have been classified into S block, P block, D block and F block elements. They are also called, S block elements are the active metals, P block elements are mainly the non-metals, D block elements are the transition metals, and F block elements are called inner transitions or the rare earths. Now let us see the classification into S block, P block, D block and F block is based on the differentiating electron. If we consider group 1 metal, they are having electronic configuration like 1s1, and in the group 2 metal it is 1s2 in the beginning, or I can say the general electronic configuration for the S block element is ns1 to 2, because S subshell can have only 2 electrons. If we discuss about the P block element, the differentiating electron goes to the P subshell and it is being classified as having a general electronic configuration ns2 np 1 to 6. If we discuss the d block element, then the differentiating electron, the last electron is entering into the d subshell, and they are having the general classification ns 0 to 2, n minus 1, d 1 to 10. And in the similar way, for the f block elements, we have the general electronic configuration, that is ns2, n minus 1, d 0 to 1, and n minus 2, f 1 to 14. Since in this case the transition of electron takes place in the inner to inner shell, that means inner to the penultimate shell. So this is called inner transition. And in d block elements, since the transition of electron takes place in the inner shell, that is why they are called transition element. And p block, s block are also like, they are known as the representative elements. Since s block and p block elements represents all the properties of the respective group member, that is why they are called representative elements. There is one more thing, bridge element. We know that there are certain elements which are causing a kind of bridging between different kind of groups. Let's say if we go Li, Na, K, and in the next group we are discussing beryllium, magnesium and sodium. Then lithium and magnesium are having diagonal relationship. Therefore, lithium is the element that is forming a bridge with the next group. Just like that, boron, aluminium, so beryllium is having some diagonal relationship with aluminium, so that is also forming a bridge. So therefore, the third period elements are known as the bridging element because they are forming a bridge with the previous group. For example, magnesium is forming a bridge with the lithium and aluminium is forming a bridge with the beryllium. So they are called bridging element. Now let us come to the typical elements. All S block and P block elements are called typical elements because they all represents the properties of rest of the group members. So there is no difference, they have no deviations from the properties, or the deviations are very few. That is, therefore they are called typical elements. Besides the typical element, we have diagonal relationship. The way we discussed in case of bridge elements, lithium is having a relation with the magnesium, beryllium is having a relation with the aluminium. It is based on size versus charge. That means in their compounds is having a charge density comparable to that of Mg plus 2. Since the charge densities are comparable, charge densities are same, therefore their properties of their elements are same. I can say one thing, in case of lithium carbonate, if we heat it up, it will decompose to lithium oxide and CO2. If I heat it up magnesium carbonate, then magnesium carbonate is forming MgO plus CO2, but if I will heat sodium carbonate, it is thermally stable, it will not decompose. That means I can simply say lithium is having a diagonal relationship with magnesium, and the decomposition of the compounds of lithium and the behavior of the compounds of lithium is somehow similar to that of the compounds of magnesium. So therefore that is called diagonal relationship. Now since we know nowadays number of elements synthesized are increasing day by day, and there is a fight for the naming of those elements. Why? Because some of the Russian scientists have synthesized, the same element is synthesized by some of the scientists in US. Now they have an argument that I synthesizes first, and I am like, let's say I am naming it Mendelevium. Some other is naming it on the basis of some of the US scientists. Some other, like just like that, there are some arguments related to their naming. So IUPAC proposed a suggestion for this, that how to name the elements which are having atomic number more than 100. In that case, they suggested certain suffix and prefixes for the element. Say for example, for 0 they suggested nil, for 1 they suggested un, for 2 they suggested bi, for 3 they suggested tri, for 4 they suggested quad, for 5 they suggested pent, for 6 they suggested hex, for 7 they suggested sept, for 8 they suggested oct, for 9 they suggested n, n. On the basis of this, if we want to name some of the element, let's say if we have to name an element having atomic number 106, then it is un for the 1, nil for the 0 and hexium for the 6. Eum is the suffix for all of them. So, un nil hexium, that means 106. If I will say 117, then that is going to be un septium. If we have to name an element having atomic number 121, that is going to be unbiunium. Unbiunium. So, that is what the naming of these elements. In this way, we have covered the periodic classification. So, in the next session, we will discuss about the periodic properties, let us say atomic radius, let us say ionization energy, let us say electron affinity, electron negativity, etc. There are a lot of the properties we need to discuss about them. Okay students, we are done with the session today. See you in the next class. Take care. Bye bye. In this way, we have covered the periodic classification. We covered the modern periodic classification and we covered a lot of the concepts like representative elements, bridge element, typical elements, transition elements, inner transition element, S block, P block, D block, F block, diagonal relationship, etc.